Yo, welcome back to the channel, man. It's your boy Street Coder Nate, and you are participating, currently watching me explain modern computers and how modern computers are just a representation of a human being. So today we're going to talk about how computers communicate because once again, like computers are just a representation of human beings. Therefore, we know how humans communicate, or do we? So we're gonna take a look at how computers communicate, and maybe we can understand how we communicate a little better, right? So let's hop into that system. All right, so what you see here, once again, this is my understanding of a computer. More so this part here, like this is the physical part of the computer for me. The display, all that is just the eyes, the visuals, the showing, for real, for real. But the real part of the computer is here. Honestly, you don't even need a display. It's this thing called a headless computer, and honestly, that's usually how I use most of my computers, headless. I don't even see the display for real most of the time. And so, um, I have it. I have this computer though, and it's upside down because it's connected to this other computer, and they're connected by network cards. Like here, this is the Wi-Fi card. I put Wi-Fi card, but it's actually the network card, which helps you connect to Wi-Fi and Ethernet. And then here is also the Wi-Fi card on the other system that the other system is connected to. So in all, this is what it looks like. You got two computers that are connected physically with a wire, an Ethernet wire. And so when you have these two computers that are connected physically between each other, what we can do is start sending data between the different computers, right? And so when we send data between the computers, well, the data is sent over. The data is kind of like packaged up, right? So let's say we had this huge Microsoft Word file that we was writing a paper on. Well, if the computer wanted to send that file to, let's call this comp one. If this computer comp one wanted to send comp two, it wants to send this document file to cop two. What happens is we're going to take this document file right here, and we're going to break it up into different packages, right? So these packages are, let's say that this file is 10 gigabytes. This is a big ass file, right? It's a big file, 10 gigabytes. We wrote a huge ass essay, and we don't want to send 10 gigabytes of data through the network all at once. It's almost impossible, right? So what we do, and that's what it's called. It's called the network. When we're the way that we communicate through a network. This physical wires is our connection, is our physical network connection. It's called the Ethernet cord, and if you connect two computers like this, you can send physically, or you'll say that they're physically connected, and that you can send information this way. And when you send that information, you break it up. You break that information up into these things called packets. So you take that whole 10 gigabyte package and you break it up into smaller packets of, like, let's just break it up into 1 gigabyte packets. That's still too damn big, but you break it up into 1 gigabyte packets, and you send 1 gigabyte at a time, and then 1 gigabyte, and then another gigabyte. And what's happening is this computer send 1 GB at one time, and then this computer's Wi-Fi card over here, there's this little buffer. That's what it's called. It's like a buffer is like a little holding zone. Like, I'm gonna take some information in, and I'm just gonna hold it for a second before I go ahead and store it in either the hard drive or the short-term memory. It just froze again. Yep. Let me see. So either the hard drive or the short-term memory. One second. So yeah, so basically there's a buffer on each Wi-Fi card. There's a buffer, and that buffer pretty much tells us there we go. Um, and that buffer pretty much allows us to store some data that's coming in from somewhere just for a temporary time, right? And so now that we got this data stored in from the temporary time, let's say we got 1 gigabyte, and then we grab the second gigabyte, third gigabyte, and let's say as each packet come by, it's telling like, oh, you got two more packets to come, and you got one more packet to come, and now you got no more packets to come. And so let's say we get that no more packets to come, and our buffer is full. Now that our buffer is full, we got that whole bitch, right? We got that whole document, and we can store that document typically in our downloads. When we get something from another place, it's typically downloaded. That's what it's called. Like you share something to somebody else, you download that information to your system. And so basically this buffer is going to connect to our downloads. And so we got this buffer. And if you watch when you download something, you can see that percentage. Like, right, that percentage is increasing of what's being downloaded. And if you try to go to your downloads and open it, it's not going to allow you to open it. But you can kind of see it there. It's just like faint, but it's not going to let you double click it until it's fully done. And that's because it's in the buffer zone. It's just letting you know that it's going to be in the downloads right after it gets done getting all that information. But it needs to get all that information first. So now that it has all that information, it then goes and stores that information in the downloads, and where you, the CPU, can go and view that information and manipulate it if you need to. That's what's happening when we communicate using a physical wire. And so with humans, that's pretty much the same thing that's happening, right? You got two people who are physically connected. How are they physically connected? Well, let's say this person is looking at this person. That's an eye, that's a mouth, or a nose and a mouth. Cool. This person is talking to that person, right? That person is talking to that person, or that person is talking to that person. And so that person's talking to that person. And so even better. This person right here is talking to that person right here. This person is talking to that person. And so you can see that kind of in a way. And so they're kind of in this way they're physically connected because they're physically looking at each other. They're physically in front of each other. There's like no virtualness here. There's all physical. We would call this a physical connection, right? And so this is almost synonymous to the Ethernet connection, because the Ethernet connection is showing that these two, they're literally physically connected here. But here, this is our way of saying a physical connection. And we send the data back and forth between by talking and whatnot, right? He talks, and this person is picking up the data that this person is saying, storing that information, processing it, and then this person talks back, and this person does the same thing. Like, we all have our own little network cards, if you will, that have our own little buffers that store information. Because, like, if this person is telling me some bullshit, like, I'm not about to store that into my hard drive, right? I might just leave that in a buffer and then just clear the buffer later on. Like, I really didn't need that information. Like, and then if vice versa, like if he was telling me something that really, like, made sense and that was going to change my life, I would take that information from my buffer and store it into my memories. And the way we store memories is like through emotions. Like, you take the information and you emotionalize it. You put emotion on that. You feel it. Is it happy energy? Is it sad energy? And through that feeling, you store that thought with it, and then it gets stored in your brain. Naturally does the storing process for you. But that's what happens when we think, when we want to store something. That's how we do it. We put some emotion behind it, and then that kind of tells our brain to store that information for us so that we can retrieve it again whenever we want to feel that emotion. Dope. Because we are feeling beings. It's an emotional process, not a thinking one. All right, cool. So that's how we processing information back and forth physically. But obviously, like, this is a more modern world, right? And we talk about modern computers. Well, this Ethernet thing was more so like a classical way of looking at computers back in the day, or an ancient way. If you old people hate me, but like an ancient way of looking at computers. But now we use Wi-Fi, right? We use this thing called Wi-Fi, and so let's take away this part right now, and let's also take away this Ethernet cord, and let's just use our Wi-Fi capabilities because we live in a 21st century. Well, how do we use Wi-Fi? Well, Wi-Fi is real weird, right? Because what's honestly happening is we're doing the same thing of taking a document and breaking it down from 10 gigabytes into 1 gigabyte packets. And remember, that's just an example, but we're breaking it down into smaller packets. And then we're going to send these packets through the ether. So you just saw Ethernet. Ethernet was that physical cable that connected to computers. Well, the Ethernet or the ether is just everything. It's the air. Like it's all the ether is all this void around us. It's all this weird black space, dark energy, whatnot that people can't explain. That's the ether, and this and through the ether is where a bunch of frequencies are just flowing. They're like we can't pick up on most of these frequencies because our or we can't see most of these frequencies because our eyes aren't allowing us to see them, but there are a bunch of frequencies all around us. And so when I say frequencies, what am I saying? Like, well, a color is just a frequency. It's a frequency of light. It's energy moving at a certain speed. That is a frequency. Like when I think of a frequency, I actually think of just a sine graph like this. Like and like the more energy you have, the higher that graph is. The less energy you have, the smaller that graph is. And then it's like then you can so that's like more energy because the graph is like the lines are bigger, right? More energy. That's more energy. And this is less energy. And you can also talk about the lengths or the lengths of these I forgot what they call the troughs or something, but basically from when this starts at the let's start here and then ends here, one whole revolution. Like how long does it take to do one whole revolution? So you can have graphs that look big like this. Then you can have graphs that have smaller revolutions like that and can have more waves and whatnot. And so this graph, we would say that this graph is a lot faster and this is slower. So you got more energy with the height. Height refers to the amount of energy. And then the number of revolutions. So I don't know the name off the top of my head. Num of revs. I learned all of this stuff offline and stuff. I didn't go to school for like the frequency stuff and whatnot. Like this is all secondhand knowledge. All right, so number of revs is and I'll probably remember the damn name later on. But the number of revolutions refer to so that's the amount of energy for height, and the number of revolutions refer to the speed at which that frequency is moving, right? And so we can only see certain frequencies because they move at certain. We can only see a certain amount of speed of frequencies, and typically frequencies are measured in like hertz and stuff like that. And so we can only see a certain amount of frequencies. Oh wait, all right, my iPad just be always disconnecting, bro. Every single video. Can I get a video where it doesn't disconnect? All right. So I'm trying to see what was the last thing that I seen. We said slower and okay, yep. Oh damn. I gotta put in some new numbers. So what is it? 5979. Enter. Okay, cool. It's gonna load up in a second. But what you will see on the screen is that I just wrote that the height is equal to the amount of the height is like equal to the amount of energy that we have, and then the number of revs is equal to the speed at which that frequency is moving. And so once again, a frequency we can see as a color. Like frequency is just energy moving at a certain speed and at a certain height. That's all frequency is. Energy moving at a certain speed and height. And bruh, why my iPad keep disconnecting? The government watching y'all. The government is watching. So let me reset that to y'all. Energy is just, or frequency is just energy moving at a certain speed and a certain height. And so we can pick up on different energies or different frequencies, either visually, either through our audio, like hearing and stuff like that. Um, that's really what frequencies is. And so in a way, frequency is carrying information, right? Frequency carries information. Like you have radio waves, and what is a wave? A wave is a frequency. These are a wave. We think like this right here. Wavelengths. There we go. Wavelengths. Okay. This is a wave, but another way of saying it's a frequency. Like it's a frequency, right? And so audio is in a wavelength. Visual things are in a wavelength. And so in a way, waves and frequency, they carry information. They tell us what this color is. Like this color is red, so you can see that it is red. They tell us that this sound that you hear is music. This is someone speaking. This is that. Like frequencies tell us information, right? And so with wireless communication, we built up off of that. We built up off of the fact that frequencies tell us information. And so we use wireless communication we use frequencies and wireless communication to pass information back and forth between computers. And so what will happen is one computer will take some data, and there's this type of thing inside the computer, like a converter antenna type of thing. Antenna, don't ask me, antenna. But it's kind of like an antenna. And what it does is it takes the zeros and ones and it turns it into light energy. Light energy being like frequencies, right? Waves. It turns it into waves. So basically, I don't know if y'all know how antennas work, but antennas like rattle back and forth at a certain speed, which will create a wave, and that wave gets shot out through the ether, and different antennas can pick up those waves. And if that antenna is on the same is listening to pick up waves on that same frequency, it will pick up that frequency. Our eyes is a system that picks up frequencies, and our brain processes those frequencies for us, and we see color. Well, we can take these zeros and ones, and we can create a frequency for those zeros and ones. And remember, these zeros and ones just represent like words and text and images. We can create a frequency for that and shoot that out to the ether. And there's another computer somewhere that's going to pick up this frequency that I'm shooting out, and its antenna is going to is listening, and so it's going to pick up that information and then reconvert it from light energy, which is just frequencies, back down to zeros and ones. And now you can see that data that was sent from this computer to this computer. And it still works the same way. So we're going to get this packet in, and we're going to say, all right, we got this packet. We got about 2 more packets to come. We got 1 more packet to come. All right, we don't got no more packets to come. Do we need to store this information? Do we need to process this information? What do we do? This is the point of wireless communication. And so computers can wireless communicate. And remember, I told you that coding, that computer science is teaching us how we think, how we work. So if a computer can do this wirelessly using the ether, do you think we can do it as well? Honestly, humans, we do it. We do it all the time. And we don't even understand that we're doing it. The reason, the way that we're doing it is by, if you walk in a room, you say, the energy in this room feels weird. What are you really saying? You're saying that your body, you have an antenna in your head. It's called your pineal gland. Your pineal gland. You have an antenna in your head that picks up different frequencies, that gives off frequencies too. Like your antenna can give off frequencies and pick up frequencies. And so we're giving off frequencies too, and we're picking up frequencies as well. And so you can feel someone's energy when they come in the room because they're literally giving off their energy. They're giving off their frequency. They're letting you know what their internal state is like. They're giving that information off, and you as another human, as an empathetic person, we're all empaths. We just don't want to believe it. Some people are more tapped in to than other people, but we're all picking up these energies and whatnot. And the thing is, we can actually control the different energies that we give off. Like we can actually communicate on a telepathic ass type shit. We can communicate that way, but you tell a human that, they're gonna be like, bro, you tripping. But on some real, like I said before, computer science teaches you, not or Steve Jobs says computer science teaches you how to think. I say computer science shows us how we're already thinking. It shows us how we already set up, and it's showing us how we can push our capabilities as basic ass humans to more superhumans, like telepathy. Like that's so dope. And on some real, I've been trying to practice this with my dog, but on some real though, like telepathy is a thing. And computers are really showing us that through the ether, which God blessed us with. God communicates through the ether. When God speaks to us and whatnot, He is speaking through frequencies, and through that we have to pick up and discern. But a lot of us, we're not really realizing that that's what's happening, because our pineal glands are picking up so much different energy, so many different frequencies. We process 60 to 70 different thoughts a day. And out of those 60 to 70,000 different thoughts a day. And out of those 60 to 70,000 different thoughts, how many of them do you think is yours? Like most of them aren't yours. Like we're going around talking to people, discussing things, looking at social media, and we're picking up energies from all over the place, and we're confusing them with our our energy, and we don't know which one is ours, and we really just get stuck and depressed and all of that stuff. So on some real, start watching yourself. Well, start watching the energy you're putting yourself around, because this is real. Like you're really not understanding how the world is putting these energies on you, and just how frequency has information in it. Well, what if that information that you pick up had a program that had a virus in it? You feel me? That had a bug in it. Like you can send a file that has a bug to another computer, and that computer can pick it up and run that file, and then the bug will crash the computer. Well, what if people are giving off bad energy, and you picking up that energy, and now that energy is inside of you, and your computer and your CPU just naturally processes it, and now you have that virus and that bug inside of you, and now you act in a certain way, which you know you didn't want to act, but you didn't know why you acting that. It's because we're picking up these random energies all over the place. Make sure you watch yourself. Meditation literally means to become aware of yourself, and that's what I do on a daily, and that's what I teach my people as I code. I'm like, yo, make sure that you're cleaning out your energy, and you know what you're picking up. Make sure you know who you are at the end of the day. You know who's writing your programs, and that you're not being programmed by the world. And so, yeah, here we go. We got computer science and we got spirituality at the same time. But yeah, on some real tip, that's communication. That's wireless and wired communication through the ether, which God blessed us with Himself. Let's learn how we can communicate. Did you know that language is a technology, and that it didn't exist at the beginning of time? How did we communicate before? How did we live in harmony with each other and our environment and the other animals around without language? It's because we already knew how to communicate without it. But I'm going to see y'all in the next video. I'm going to get with y'all. Peace.